going to continue in section 2 for my Team U students or anyone else who didn't get enough information about the last bit of section 2, starting at luminosity on page 26. Actually, let's start at Yuri Gagarin. This is another one of these postage stamp pieces that I'd like you to take some time to read through. Yuri Gagarin was the first human being to be in space. Again, the USSR is the one who accomplished this. So now the United States is getting really, really anxious. Sputnik going up first, Gagarin going up first. All of these things really make the United States nervous about its own capacity with regard to the space race. All right, so let's talk about luminosity. Luminosity and apparent brightness are two contrasted terms here. So you can think about this in terms of yourself standing on the Earth, looking out at a star, and I'm just going to use the star Betelgeuse for reference here. Betelgeuse is out there shining himself away, and he's happily shining at his luminosity, okay? His luminosity doesn't change depending on where you're at, okay? You could be right on Betelgeuse, or you could be far away, and he's still out there just shining. That's the luminosity, regardless of where you're at. Where you're at determines its apparent brightness. Obviously, it's going to look a whole lot brighter if you're on the star itself than if you're here on Earth. So that's the difference between apparent brightness and luminosity. Dropping down to magnitude scale. This is a scale just being used to measure the brightness of a star. Absolute magnitude, that's the measure of luminosity that the star is actually radiating into space. This brings us to figure 2-11. This is an example, well, it's the first of the Hertzsprung-Russell Diagrams. This is from a paper they created where they proposed this work. So now I'm going to go down here. We're going to talk about the Hertzsprung-Russell diagram. This is something that gets used a lot. You're going to want to try to understand this a little bit. This diagram shows the basic relationship between luminosity and temperature. Okay, so logically that makes sense, right? If something has a high luminosity, it's probably got a higher temperature. But there are some stars where that just isn't the case. So this basic relationship is diagrammed in that Hertzsprung-Russell, or HR, diagram, and it's luminosity versus temperature. So now let's go back up here. The luminosity and the temperature in the HR diagram. Notice how there are some stars that really just don't seem to fit in logical space. We're going to talk about that as we talk more about the HR diagrams. Okay, so here we have an important date in the United States. Remember, we're getting really nervous about Sputnik and Yuri Gagarin. We've gotten a satellite up there, but we haven't done anything before the Soviets have. So 1961 is a really, really famous speech from John F. Kennedy saying that we're going to go to the moon. So that's very important for you to remember. Read the postage stamp. It's quite interesting. Okay, so this section here, Hertzsprung and Russell are plotting temperatures and luminosities on their diagram here. So temperature is spectral class, luminosity is absolute magnitude. And they find that stars are generally not scattered throughout the whole diagram. There's kind of a band. You saw that band that goes, here we go, diagonally from the upper left down to the lower right. And 90% of stars fit inside of that band. So this is really fascinating to them. And it proves this sort of logical idea that luminosity and temperature are related. The brighter a temperature, or the brighter a star is, the higher its temperature tends to be. So in other words, cool stars tend to be faint, hot stars tend to be bright. That is called the main sequence. That diagonal band is called the main sequence. So here's some of the stars that you're going to find in the HR diagram. Red dwarfs, relatively small, cool main sequence. They're in the lower right corner of the HR diagram. So red dwarfs down in here, okay, lower right-hand corner. Then you've got giants. They're off the main sequence in the upper right. That's up here. These are cool stars, but still really luminous. So these guys are kind of outside the logical sphere. What this tells us is they have to be larger than these main sequence stars with the same temperature. Otherwise, they wouldn't be able to be more bright. Then down in the lower left-hand corner of the HR are white dwarfs. So I'm going to go down here and highlight this information so you can find it. Here's your giants off the main sequence in the upper right of the HR diagram. Relatively luminous, but cool. Then in the lower left corner, we have the white dwarfs. High temperatures, but low luminosity due to a relatively small size.